Hello, everyone. Welcome to DevOps Stage 2024. Thank you for spending time and attending this talk. This session is pre-recorded, and I welcome you virtually. The topic that we want to talk about today is Kubernetes GitOps with ArgoCD, best practices and practical patterns. But maybe before starting, I can shortly introduce myself. My name is Maryam Tavakkoli. I'm a cloud engineer working at Relax Solutions. I'm also a CNCF ambassador and a Microsoft MVP. I'm based in Finland, Helsinki, and I co-organize Kubernetes and CNCF meetups in Helsinki. In my free time, I also write some technical articles in my Medium account, and you can find me on Medium or LinkedIn. All right, here is the agenda that we have for our talk today. First, we will have an introduction about GitOps, what is GitOps, and then we are going to review benefits of GitOps. Then we will introduce ArgoCD, and after that, we will have a short demo to see GitOps and ArgoCD in action. And after that, we will explore the best practices and patterns with ArgoCD. And finally, we will summarize our talk. So let's get started. Let's start from definition of GitOps. GitOps is an operational framework based on DevOps practices such as continuous integration and delivery, CI and CD, and version control, which automates infrastructure and manages software deployment. I have also included a nice definition from gitops.tech here, which states the core idea of GitOps is having a Git repository, which always contains your declarative descriptions of the infrastructure or code, which is desired to be in your environments. And then one automated process which makes the environment matching the described state in the repository. So if you want to deploy a new application or update an existing one, you only need to update the repository, and the automated process handles everything else for you. So it's like having a cruise control for managing your applications in your environments. Let's quickly have a review over the GitOps principles. These standards are stated in the Open GitOps project, which is a CNCF project, and it comes from GitOps working group. So according to this standardization for GitOps, we have 4 principles. The first one is about declarative descriptions, which states that infrastructure and applications are described declaratively, and GitOps ensures that actual state matches the desired state. Then the second principle is version control as the source of the truth, which states that all infrastructure configuration and application code that you have are all stored in Git repositories, and this will ensure that all the changes are tracked, versioned, and if needed also, they can be rolled back. Then the third principle of GitOps states that you need to have pulled automatically, and the changes to the system are made through pull requests in Git. Once the change was approved and merged, the automated process behind the scenes applies those changes to the infrastructure or application. And then the last principle is about continuously reconciliation. So GitOps operators, either it's ArgoCD, Flux, or any other GitOps tool, continuously monitors system's actual state and compares it with the desired state, which is stated in the Git repo. And if there is a drift from the desired state, the operator automatically reconciles the differences to restore the current state in your system. So these are the principles that any GitOps tool should have. So this Open GitOps project has tried to make sort of a standardization that how any GitOps tool should look like. And now that we have become familiar with the concept of GitOps, let's also review the benefits that it brings for us. So the first benefit is consistency and traceability. So all the changes in this approach are tracked and stored in Git, which provides a complete history of all modification for you. The second benefit is about automation and efficiency. The infrastructure and application deployments are automated, which reduces the human error, and it also speeds up your delivery process. So this is also a nice benefit that it brings. An important benefit is security. By using Git as the central control point, you only those changes which are reviewed and approved via pull requests are applied, and this way you have enhanced security, and it also reduces unauthorized changes. And last but not the least, easy rollback. Since all the changes are versioned in Git, rollback to a previous state is as simple as reverting to a commit message in this GitOps approach. All right, now that we have become familiar with GitOps and its benefits, it's time for introducing ArgoCD. ArgoCD is a declarative GitOps continuous delivery tool for Kubernetes. It is designed to facilitate deployment and management of applications in a Kubernetes cluster using Git as the source of the truth for the desired application state. So as you can see in the picture, the ArgoCD controller pulls your changes from Git repository and it deploys those changes to your Kubernetes cluster. Here we have another picture which compares the traditional push-based model compared to the new pull-based model that GitOps provides. So traditionally, perhaps you had your Git repository with your configuration, and then you had some sort of a scripts for CD, which had access to your cluster, and it was pushing those changes to your cluster, and you were like in a schedule running that script once in a while. However, in the right side, we have the difference in the pull-based model, which ArgoCD works based on it. The ArgoCD controller has access to Git repository that you have definitions for your application or infrastructure, and it pulls those changes continuously, and it syncs those changes with the state of your cluster. And it does this continuously, making sure that always changes which are desired and are declared in your Git repo are in sync with the current state of your cluster. All right, now that we have seen the definitions, the benefits of GitOps, and introduction of ArgoCD, it is time for us to have a short demo so we can see lots of these in action. I have provided two links here. The second one is the getting started documentation of ArgoCD, where you can start everything and follow from there. If you haven't yet worked with ArgoCD and if you haven't even installed it yet. And the first link is the repository that we are gonna have a demo based on that today. So you can use it later on as well. Let me go to the browser here. I have a Azure Kubernetes cluster that I have deployed ArgoCD on top of it, and I'm using it today for our demo. Here is the documentation, getting started documentation that I mentioned of ArgoCD. So you can start from here. Installing of ArgoCD is as easy as running a kubectl apply, a YAML manifest on your cluster. However, the way that we have installed it today in our repo, so this is the demo repo that I mentioned, we have a customization.yaml, and I have included definition of ArgoCD Helm chart here, along with a bunch of YAML files. These are basically the ArgoCD application definitions, which will be also installed as part of this customization.yaml. So since I don't have any ingress in my cluster, I will use this kubectl port forwarding service of ArgoCD to access the UI of ArgoCD. So let me open a terminal, and I can do a port forwarding, and here we should be able to access ArgoCD on localhost and port 8080. The first time that you log in, you can get the password using this ArgoCD CLI command, ArgoCD admin initial password. So let me get the password. And log in here. All right, we have our ArgoCD UI with a bunch of applications. Let me go here and open the application manifest of ArgoCD. And maybe before even explaining about this, I can go back to the slides and we can have a definition of ArgoCD application. If you aren't familiar with it, an application in ArgoCD represents a Kubernetes manifest that is managed and deployed by ArgoCD. It defines the desired state of the application, including source of the application manifest and the destination cluster where it should be actually deployed. So let us come back here. As you can see, there is a source section in this application manifest, which states that I have this repository for our demo and branch, and then it points out to the root of this repository to look into here, and it observes all the changes which are coming to the root, and it should sync all the changes here to the actual state of the cluster. And the destination where it should deploy these changes is the local server in the ArgoCD namespace. So this is the one that we were looking into. This is the ArgoCD application called ArgoCD, which is created, and it creates a bunch of ArgoCD resources, which are in the Helm chart, as well as a demo app set application set. So this is, we have here a bunch of applications, a guestbook and a hello world, and both of these are just simple YAML manifests, including a deployment and a service. So I want to also install these applications on my cluster using ArgoCD. How can I do that? The very first solution is that you can have one ArgoCD application per each code that you have. So I have one here, which is referring to the applications folder and hello world folder within it. And then I have another one for guestbook. This works fine, and it can create these applications. However, we have another way to define ArgoCD applications without repeating ourselves 2 times for each of the code manifests that we have. And for that, I will share the slides once more so that we can go through definition of application set. Application set is a higher level abstraction in ArgoCD, which allows you to define and manage multiple applications based on a template. It enables you to dynamically generate and manage multiple instances of a similar application using a set of parameters. So let's go back to our demo repository. I have included one other YAML file, which is an application set definition for installing the hello world and guestbook code. So using an application set, as it was mentioned in the definition, you have some sort of a generator section which goes through a list of clusters or As an example here, it goes through some folders, some paths within your repository. So I have mentioned that I want to go through the applications folder, and it should go through any folder which is located under applications folder and generate an ArgoCD application for me based on these templates that I have here. So what does this template say? It says that name of the ArgoCD application should be equivalent to path.base name, and base name comes from the name of the folder that you have in the path. So if we can look into the ArgoCD UI, we can see that each of these applications are called according to their folder names. And then I would say that I want to source be this repo, the main branch, and the path should be equivalent to the path which is built here. So one time the path is built based on guestbook, and the other time is built based on Hello World. So these application set in reality would create two different applications. This one, so it creates two different applications. So an application set goes through some template, and it goes through the generator list that it has, and it generates one application per each entity in the list. All right, now we can do an experiment. So if we look here in the Hello World, it has one replica. Let's look into the UI here. Yes, it has one replica, and we can also ensure that here in the cluster. So let's do a kubectl get pods, and we can see there are a bunch of ArgoCD pods running and one Hello World application. So what we want to do is to see how ArgoCD syncs the declarative definition in repo, the desired state, with the actual state in the cluster. So let's go ahead and change the replicas to 2 and commit this change. In the real world, you will do a proper pull request, have approval for it, and then merge it. But here I'm doing a simple commit, and to speed up things, I will sync it manually. So we should end up with 2 Hello World pods. If I do a hard refresh. Yes, so let's also check in the state of the cluster to make sure this, even though Argo UI shows this for us. Now we have 2 Hello World applications running. So this is how ArgoCD syncs the desired state with the actual and current state in the cluster. And we have also seen the definitions of application sets and applications, and how you can manage your applications using ArgoCD. All right, let's go back to the slides. Now that we have seen some ArgoCD in action, it's time to talk about best practices and patterns that exist with ArgoCD. When you want to start with ArgoCD, perhaps the very first question that comes to your mind for your project is that how should I manage my clusters? Should I connect one cluster, child cluster, to one control plane? Should I have in general one control plane, or what is the best practice and suggestion? So very first option is that you can have one control plane and connect any child cluster that you have to that single control plane. However, the drawback of this method is that you will end up with a single point of failure. So if this single control plane fails for any reason, then you are losing multiple child clusters as well. But it might make sense for a small project where you have just a few clusters and you don't want to increase the overhead of management for yourself for managing and maintaining these control planes. The second approach could be that you connect one control plane per child cluster, Of course, it will increase the maintenance overhead for you since now you have more number of control planes that you need to manage. However, it also doesn't have that drawback of single point of failure. So again, for a small scoped project, this also would work. However, if you are talking about bigger projects and bigger companies, maybe none of these would work. One has a single point of failure drawback, the other one has management overhead, which might not be reasonable for very big projects, very big companies. So a trade-off might be the third approach, where you can have one control plane per logical group. This logical group can be an organization category, it can be team based on teams or anything else. So you can have one control plane per organization and connect a few different child clusters to this control plane. And this is usually the way that it is done in production level projects, and many companies might be using this approach in a bigger scope. And next pattern is managing ArgoCD with ArgoCD, or in other words, in a larger scope, using app of apps pattern. So as we saw in the demo, we had on a customization.yaml, which included definition of ArgoCD Helm chart, and it was being observed by that very first application that we saw, the ArgoCD application, which was pointing out to the root of the project, and it was observing all changes which are coming to the root of the project, and it will sync if there were changes. So that customization.yaml was also included in that ArgoCD application, and this is the way that we are managing ArgoCD with ArgoCD, meaning that if we were to make any changes to the ArgoCD Helm chart or it values.yaml that we had in the repo, the ArgoCD application that we had would catch that change and sync it to the state of the cluster. Of course, the very first time that we want to install ArgoCD, we need to do a kubectl apply command, but this is about after that continuously making sure that changes are in sync with the state of the cluster, also for ArgoCD itself. So in general, this app of apps pattern is to define a parent application that manages multiple child applications. So you can use it for other things, that not only installing ArgoCD or managing ArgoCD, but also for your other applications. And this is a industry practice, this app of apps pattern, and you can use it. Another very nice feature of ArgoCD, powerful feature, is application sets, which we also had an example in the demo, where you could have a generator section which ArgoCD application set goes through, and it generates one application per each entity in that generator. So it could be that you go through different clusters using that generator. It could be that you go through different paths, as we had in the example, or any other combination of these. And then you will create one application per entity based on a template that you are providing. This is a really powerful feature. It allows you to not repeat yourself as much as possible when applicable. In our example, we had two different codes for guestbook and hello world. We could repeat ourselves, as we saw, with defining two different ArgoCD applications, or we could just generate one application set and one YAML file which goes through a template and generates those applications for us. So use application sets when you have multiple similar applications that requires a consistent configuration across environments. For instance, if you're deploying microservices or managing environments for multiple teams. Application sets lets you define a single template to manage all applications uniformly. The next best practice that we have is about using Helm and Customize as application sources. In our example, if you remember, we were pointing out to a Git path as the source of application, and it was quite fine because we had just two single and simple YAML manifests. However, in your projects, you might have your application not as a YAML file, but as a customization overlays or as Helm charts. And if you have such use cases, you can use Customize and Helm as the source in ArgoCD application, and it provides some nice features for you. If you are defining the source as Customize, you can have patches for it. And if you're defining Helm, you can pass value files in different methods to ArgoCD applications, which is quite handy if you have such use cases. Helm is ideal for managing parameterized configuration, enabling templating, and sharing deployment templates across teams or environments. And Customize is useful for creating layered configuration and allows you to apply environment-specific overlays without duplicating the manifest files. So this is also a really powerful feature, and you should use it in production if you have customized or Helm applications. The next best practice or pattern that we have is automatic syncing, that you should use it with caution. There is a section also in the application definition of ArgoCD, which allows you to define the syncing process to be automatic or manual. And it makes total sense for dev and staging environments to set that syncing to be automatic. So as soon as there are changes in the Git definitions, it will also continuously deploy to the current state of the project, state of your cluster. But for production, maybe it's a better approach that you let those changes happen in Git, you review how it looks like in dev and staging, and then with a manual sync, you allow it to be deployed in your clusters. So the point is that use this automatic syncing with cautious, because if you have it set to automatic on production, it means that you will continuously get the recent changes in your Git repo. And if there has been some mistakes or issues, you wouldn't catch it in time. And then the last one that we want to talk about, and very important one, is about handle secrets securely. So you shouldn't store sensitive data such as secrets in your Git repo, even though you are defining all the desired states in Git. You shouldn't store secrets. So what should we do? How can we pass secrets? You should use the external secret management tools. You can use Azure Key Vault, HashiCorp Vault, or AWS Secret Manager. And then you need some open source, some tool that integrates those secrets from your secret management tool to ArgoCD. And those tools can be any open source project which is out there. External secret operator is a good one, and you can also use sealed secret. All right, with that, we can summarize our talk. We started with some definition of GitOps. We mentioned that it's a method to manage infrastructure and applications using Git, providing a source of truth. Then we introduced ArgoCD as a very popular GitOps tool, which automates deployments by continuously syncing Git changes to clusters, ensuring that they always reflect the desired state. And after that, we had a demo, which we showcased how changes that we had in the application in the hello world was being synced to the state of the cluster. We also observed how application manifest is built in ArgoCD and how we can use an application set to generate multiple application templates. And after that, we discussed the key best practices that are out there to use ArgoCD. We mentioned securing your secrets, be cautious when you use autosync. You should use app of apps pattern, especially for managing ArgoCD with ArgoCD. And we also mentioned about application sets, which is a really powerful feature, and also the source of your ArgoCD application can be Helm or customized if you have that use cases in your project. All right, with that, we can finish our talk. I hope this has been an informative and helpful talk for you, and have a great day.